Hello, everyone. Welcome to the second week of the course that is about overview of GIS and where we are standing. Before getting started, I like to ask you a question. Do you think how the GIS can shape the future? And what is our role in making a peaceful environment through those spatial data? And how can we collect spatial data? So having said, this session is going to have a whole overview. I know some of you, or maybe all of you, know about the GIS, but just recall our brain and mind what to do, what to not do, and where to go. So the learning objective of this course, we are just aiming at recalling our learning and why we use indeed GIS in daily life. And as you can see at the top, 17 goals of sustainable development goals. What is the linkage between GIS and them? We have to explore throughout the course indeed, but not only in this course, listen. Then a component of GIS, I know everybody knows, but just recall applications and challenges. What are the challenges mainly I'm going to talk, and what we think about the future. And the next probably 1-2 classes will have also the future of geospatial trend. We'll talk about that. Then we'll come with some also example. I'll show you the website, the links for open source data APIs where you can use it for your own work. Also, there are many others I can provide you in person. If anybody writes me email, that's fine. I can provide it. Then we go for research and innovation frontier. So the brainstorm, as I ask you, you pause the video and think about 2-3 minutes about what needed urgently for disaster management to help strengthen the prevention and loss reduction impacts for environmental changes through geospatial data, through GIS. So what are the roles we can make it? So having said, when we talk about geospatial data, and the definition of GIS, of course, this is about a collection of computer. This is very general definition, software, geographic data, and also methods, people, and so on, analyzing. Now, techniques depends on how the people they go. So mainly we do, this program especially designed to assist in a solution of any geographical problems. But from the other side, we have the concepts or ideas, and also everybody might be different. So we have to think about that, and for the justification and so on. So from the other side also, we think about a modeling GIS, right? When here we do analysis and modeling, this is a part of GIS, but GIS modeling is a process indeed. So this process requires different ways of thinking about the word than many other use, perhaps the people that do. So firstly, we have to think about the importance, what techniques we can apply. And this is all about coming to a definition and from person to person might be different. Typically when applications comes in, and we'll talk about the application. But before going to geographically reference, as we say, all data should be, but typically the data, they are like latitude, longitude, or northern, eastern, formats and standard formats. When we talk about standard formats, okay, when we talk about standard formats, what exactly standard formats mean, right? When exactly it is. So I'm touching some of the points about the standards geographical data. Okay, so there are many definitions indeed, but all incorporated the, some central elements. A standard indeed is a document agreement between providers and consumers, right? Established by consensus that provides rules, guidelines or characteristics, ensuring material products and services are fit for any kind of purpose. So well, others, are documents provided by detail on the business value for standards. Behind the scenes, indeed, standards make everyday life work, right? So I'm not going to into the detail of that, but when we talk about establish the size, shape, and capacity of a product, a process or a system, and so on, there are many other things like that. So so this is this is about a standard, but again, we talk about something about open data, open standard, right? Typically, when it comes to policy of publicity available and policies and license, no license, vendors, data, neutral, and so many other things data we have. So let's come back to the GIS, the story of GIS, and now we are talking about the Open GIS in 2022, right? So if the story goes back to 1963, development initiated, and ESRI 1969, and go on, then it goes to 2000. GIS passes a couple of like $7 billion with more than 1 million users. Then we have many users. Then here we do have also, now we work with the APIs, imagery in actions, GeoAI, and so many other things, right? But typically, when here we talk about a big, we talk about the big spatial data. There are lots of big data, and how we can find them indeed into GIS performance for any kind of operation we want. This is not only about what is at or where is it or so on, but we are talking about big data in this generation. Big data have emerged and become the norm in the past decade. With it's well known. So there are many challenges, scientific research and the development of new applications through GIS, and such big data are normally used to record phenomena of interest from social, physical, and economical perspective. So here in the past decades, big actually data, especially temporal data mainly, have driven and enabled innovations in all aspects of information systems, from hardware, algorithms, software tools, to applications, and fostered actually the integration of different traditional disciplines to enable new research directions. So that's why we are here gathering, and we have to find the new directions about that. This is not only about the slides I show you here. There are many other things. Again, big spatial temporal data analytics more efficiently when discovering trend and pattern in various domains from human dynamics indeed. So we have to think about different sides. So there are many other things. Literature review can be found actually in the paper I'm going to provide you, and perhaps that can help you in the big data and show you how perhaps it works then. So the other side, from the other side, what we do have also future direction. We have another, you know, we do have another class. Mainly we talk about the future and trends, but here future direction of big spatial temporal data present a challenge to automate the extraction of actionable information and knowledge, right? So the need for more accurate and reliable understanding and prediction required improvement to sensors and system architecture. We need to design a system. It's not only about you know, GIS working with some data mapping and so on. So we do have analytical methods as well. We have to work on data processing too. Think about like this way: geoprocessing, we do have in ArcGIS, we do have in ArcPro, right? But can we think about artificial intelligence and machine learning, deep learning, and so on, or geoprocessing technique to generate a map from one step to third step? Then just only put in the back end on the cloud, so everything can be done and easily. So in improvements to big spatial temporal data, science required improvements in rules and the way of technique. We need also the policy indeed, right? This is not only about the definition here that I've given you. A GIS is an information system, right? Or somebody said this is a powerful, for example, this just putting the layers together here, as we said, you know, how it works, you know, stored and so on. Put the layers and analyze and having the topological relationship among, you know, the objects, so we can, for example, you know, generate a map or a good map and so on. Or this is not only now about the component of a GIS, you know, software, hardware, data, people, and method, and so on. Here we do have social media data. What techniques actually? There are a number of techniques like CNN, RCNN, fast CNN. Many, I mean, techniques are there we can apply. So the methods based on the application, the technique based on the application, then produce a software, produce a new, you know, app. So there are many other things also in terms of computer hardware. Also, we do have some of now new things coming up, like Cloud, for example, or Google Cloud. Myself, for example, I did in GeoIME whole design system as an ecosystem in a cloud. We use Google, we use, you know, Microsoft, we use also Huawei, and so on. So again, about the software here, you know, the computer software in GIS is not only about ArcGIS or, for example, Web Tools or some other software, QGIS and so on. Here we think about our own algorithm development. There are, as I said you, and in the next video, I'll show you the API and everything. So I mean, you can use them, and based on your own, you can modify them. So again, about the people, the main thing is that how we can engage people. The participation of people means good and having powerful GIS. So, but the question again, the challenge is how you want to involve all the people, right? And data gathering and so on. There are also a few website. I'm going to show you link how to generate the story map, for example. We do have also a lab over there, that one. Then about the data, so we have a different data, you know, from satellite imagery to, you know, analog and so on. So, but let's again think about the mapping. It's not only about the mapping actually when we talk about geospatial data here. As I said, geospatial data describes aspects of the natural and built environment, and has three components, which is location, attributes, and time. I'm going to show you also some of the features that. So time is very important, right? So location is about where with the location of a mapped phenomenon often is indicated by an address, for example. Okay, where is your home address and so on. We know all about these things, but the new technologies, the new things, Internet of Things comes and bring revolutions actually in GIS, and we have to think about the better way to, how to do it. So in terms of again, coming back to, for example, the good things, we have to talk about example. Let's give you an example. Okay, yeah, I'm going to the next slide. Maybe take a rest, 5 minutes, and pause again, come back. I hope you pause and come back now. So who needs a GIS, and what is the example I'm going to show you that. So as we know, everybody needs GIS, like actually from daily life, you always use the GIS and so on, even though when you wake up and so on. So there are a bunch of applications. I'm going to show you geology, archaeology, railways, transportation, and so on. So this is not only about a map. GIS is more than a program, a map, actually, as I told you. For example, let's think about let's think about something like chain navigation, grid based on cellular automata for large scale crowd, for example, and evacuation, right, in virtual reality. So how could we use a virtual, virtual reality indeed, right? So this is something in new GIS we can find. Augmented reality, for example. Okay, augmented reality. This is not only about the map, the tables, the graph, the report, mailing list, and all these. These are all we know. As we know, for example, features might be point lines or polygon and so on, right? But the large, when I talk about an example, a large scale crowd evacuation simulation in virtual reality is of great significance of emergency response. Then their GIS play a major role, right? However, the existing large scale crowd evacuation simulation methods are challenging to apply the virtual reality scene, right? We do have our scene and so on. So here, the virtual reality is a big problem. This is just an example I give you, and there are other examples we can explore. Thus, the efficiency of a large scale crowd vending in virtual reality needs indeed to be improved. So maybe some of you wants to do that. If you want, I can provide you some related paper. We have already worked on that. So sorry, here then talk about two basic types of information in GIS. Indeed, also we have, but again, when we talk about the type of GIS, data, whether it is spatial information or this is descriptive information, all we know. But the reality is that how much they're accurate, how much they are in time, and what really we can do with them, right? And even though nowadays smartphones, for example, we do have lots of data on data. So then we do have the linkage of with data and geographical information about the particular features and so on, as you can see here. Then, as I told you for the modeling in the previous slides, it's a very challenging actually, and I can feel that modeling is even though it's a big topic actually to work with that. So there are raster GIS modeling, for example. I'm sure you have gone through that one, even though in the lab we might like to do some of the model with point clouds actually to model, DTM, DSM, and so on. We do have also some other modeling like spaghetti modeling, tin model, and so on. But do have the nature of data. We should know about the nature of data when we talk about, all of them. So here, I'll just go with the next. So, but one thing is important is to know again. I know all of you have passed remote sensing, but I'll just recall in your head to your head. So, remote sensing is the technique to without physical contact, collecting some information from through satellite images, extracting information from them, even drone or lidar or point cloud. So this can be a one of the input data into the GIS and the work. So like for example, here we do have airborne, mobile scanning, laser scanning. I mean, terrestrial laser scanning. You do have, and backpack and so on, and also drones or 360 degrees and so on. So once we do have the high resolution, and satellite images or drone images, of course we do have a better data in GIS than we can work on that. But again, is about the prediction, how you work to predict. So here there are input data. This is an example of, for example, of chemical actually release. So emission, they have the inventory and they work on that physical and so on. But I'm going to touch a very good point in the next slides. I will talk. So for example, again here, based on that chemical, emission, chemical emission inventory. So they generate a model here. So based on this score, kilometer areas, the number of hours estimated exposure, and they use, for example, receptor. Of course, you can also use SVM and support vector mission and so on to generate some of your own model and so on. So here another example of the good model, for example, you have in highlighting those answers. So there are one bunch of applications here. What you can see, these are all the projects we have done actually, from deformation, ground deformation, to environmental, coral reef, dynamic change, virtual reality, evacuation for the subways, and mapping disasters by using drone and so on. So here again, here for example, here again you have a flood modeling, virtual modeling, 3D modeling. Here you have also mangroves, a special temporal extends. Actually, we have work. We do have also GIS in road marking, mapping, and so on, earthquakes, geology, and so on. There are many others, like for example, agriculture. I think we'll go to have one good lab and lesson about the dynamic maps of how we use, deep learning and machine learning to identify the type of the crops and also estimate the yield. So we do have also deep learning methods, techniques in line slides using within GIS, actually utilizing GIS. So we do have also some urban and so on. There are many actually applications. So this is all about the overview from the beginning to now. But now we do have sensors, we do have point clouds, as you can see here, right? On point clouds on our aerial photo. We do have agriculture, we do have autonomous driverless laser scanning, system. Then we do have a digital data. Actually, this has become like a growing and growing, and all governments, organization, and business like base their decision and make decision based on those data, digital data. So the volume, the size, the speed, diversity, complexity is becoming more and more. And with geospatial data is generated, require change. So that's why we are thinking about change. That's why we need to have a talent ideas, how to shape future. This is about automation. Now, using Internet of Things, big data, artificial intelligence now, rising a digital tool. How we can cope up with this speed? Which innovation occurs represents great opportunities and challenges to us. And that is trying to prioritize the effort now. So we have to think about this way. So again, I'm coming back to one of the other example we have recently, drawn a framework for improving representation efficiency of disaster information. The paper is with me. I'll give you. This is about a virtual landslide disaster environment, but also for the others we can do have. As you can see at the bottom here, we do have satellite, tweeters, and social medias, and so many other things we define actually, virtual reality, augmented reality. So the GIS actually nowadays should go through that way to make it virtual, to make it real, augmented reality, footprints of what we need to do. So that's why when we think about globally, right? When we think about it globally, they have actually the model for geospatial strategies in the United Nations. So as you can see here, there are some partnership data standards, capacity buildings, and talents. So policies, governments, innovations, educations, communications, these are all together should work to make something happen. That's why SDG 17, number 17, it's all about a collaboration, cooperation, working together to make a peace work. And I think GIS and geospatial data, with the help of citizens, with the help of integration and good idea, nice techniques, we can make something good happen. And not only the, for this present, but also for the future generation. So there are goals over there. So 4 or 5 goals in this way we can say. So again, as a closure, before going to closure, I like to share something with you, which is very important indeed, which is very important, and the role of geospatial information achieving 2030 agenda of SDGs for sustainable development goals. What I mean, I think is that most notably for the SDGs, 2030 agenda recognizes the value that geospatial information provides to enable informed, data-driven, and decision-making. The importance of geospatial locations and from location information, is clearly highlighted by the SDGs goal 17. As I told you, this is all about a partnership on the strengthen the means of implementation and the global partnership for sustainable development. So we need to think about a capacity building, right? So then thinking about the delivery value, the deliverable values through the geospatial information, that is Earth observation system on geospatial information data combined together with socio-economic and other statistical data that provide unique input to governments in their policy operation, right? So monitoring and evaluation, the data along with digital development and industry innovations mentioned elsewhere, in our course in future also we talk, will play a large role in global, stewardship, enabling faster, more create and trustworthy information to be made available. That's all we have to do. And education, I think, is one of them that can help the decision maker to inform decision, monitor progress, and assess the impact of intervention. So we should talk about the future of and the future of geospatial and the data and also GIS in the next lectures. There are many other things I want to share with you. There are too much, but I'm sure you get bored with my long talk. And I thank you very much indeed for listening. But as a closure, backing to the closure, we conclude the improvement in a spatial data and spatial data infrastructure that will require the transition. So everything, as you can see here, it should be in 3 steps in future. I mean, everything from front end should go to the back end and open source, open software. So I can share with you more if you want. Ask me question. I'll come back with you to all respond, and I respond to all questions. It needs actually network of data analytic expertise and policies. This is not only about the data, we generate the data. What about the policy? What about the legitimacy? What about the accuracy? What about the real time? I mean the time, the right time there should be. Then what about the integration? So spatial knowledge into every decision making and problem solving we should have. So we require transition, as I told you, but from now to next 5 years to 10 years, we'll talk in the next slides. I mean, in the next classes. Hopefully, we have a session for that. We'll talk about the maturity and application of already been established technology. So we should concentrate on those and integrate. I think all can help you to develop your ideas into a good, research, maybe your thesis and so on. So, for example, GeoIME, Geospatial Infrastructure Management Ecosystem. And the next video I'll show you is some links and website you will see, but more detail will work separately. So that I leave it to you, and I need you to think about that. Come back with this response to how do you connect the geospatial drivers to shape the future of GIS in cross-disciplinary. Share among your colleagues the answers, and let's discuss about it. Okay, it's not only about the GIS, what we have, the maps and so on. There are many other things like smart cities, transportation, electronics, many other things can be involved. So we have to have some geospatial drivers and trends. So we'll think about this way and come back and post your answer, post your response on D2L if you can. Otherwise, send me email. That's fine also. So there are some bunch of links. I think they would be helpful to you. If you need more, I'll give it to you. I need also my own data. I can provide you if you need to work. And thank you very much for listening. May and take your time. I appreciate you. In the pandemic situation, we are all cooperating together to make the world peace. Thank you very much and see you later.